All right, so what we have here is we have an equation. It's got a variable g, and we have two matrices going on in this equation with it. What's going on between this first matrix and g? What are we doing between those two things? We're adding. And so if this was something plus something and we wanted to solve for one of the variables, how would you get rid of the other thing? You would use subtraction. So what you're going to do is you're actually going to subtract. I always do this. You're going to subtract this matrix. And where do we subtract this matrix from? We subtract it from the other matrix. So essentially we're saying, hey, this matrix here plus g equals this one. So what does the G matrix have to be? Well, if you subtract this over, then that will tell you what G is equal to. So we're going to subtract that matrix. So then that will give us what G is. So negative 6 minus 3 is negative 9. Remember you subtracted the spots, right? 4. Page 4. And then in the second spot, we'll have 8 minus negative 9. So minus negative means to add, right? So 8 plus 9 is 17. 6 minus negative 1. So 6 plus 1 is 7. And 12 minus 5 is also 7. Yeah. So if you were to put this matrix in right there for matrix or for that G, this one plus this one would give you that one. What do you think? Super crazy? No, right? It's just like, hey, if I ask you to solve like x plus 4 equals 10 and you subtract 4, right? But instead of subtracting one single number, you're subtracting a matrix of numbers. So it's essentially like 4 of those equations built into one. All right. If there was a subtraction sign between them, you would do the opposite of that, right? So if this said like G minus this matrix, you would add it over. All right. We are going to go over this guy next. So solve this matrix equation for P. We have what it's supposed to equal, and it's this matrix times P. So here's where we get into the division. Technically, if it's multiplication, you want to undo it with division, right? But we've said, hey, division doesn't actually exist in the world of matrices. Instead, we have to use the inverse. We're going to have to use the inverse, all right? So the first thing we're going to do is we're going to find the inverse, and I'm going to show you how we're going to use it, okay? So what matrix do we want the inverse of? The one that it's equal to, or the one that's being multiplied by P? The one that's being multiplied by P. So this matrix right here, you need to find its inverse. So start by finding the determinant, right? So what is the determinant of that matrix? Negative 1 times 5? Negative 5. 0 times 3 is 0, and you subtract those, right? So we get negative 5. So when we go to find the inverse, we'll use 1 over negative 5 in the front. And then what do we do for that inverse matrix again? Yeah, switch these two spots, right? So this becomes a 5 and a negative 1. And then you switch signs, so that's negative 3, and then 0 is just 0, right? All right, and then last but not least, your actual inverse matrix is what you get when you multiply all of those by 1 over negative 5 or divide them all by negative 5, right? So the first one, 5 divided by negative 5 is really nice. That's negative 1, right? 0 divided by negative 5 is just 0. Negative 3 divided by negative 5, that's going to just be positive, isn't it? And 3 over 5 doesn't simplify at all. And then the last one, 1 over negative 5, that also just turns positive because it's negative 1 over negative 5. So here is our inverse matrix, all right? All right, so what we have to do now that we have the inverse matrix is we're going to use multiplication. So if we multiply this matrix by which matrix will we get the identity? Because remember, that's the whole point of the inverse. You can throw it out. And we're on page 4, right? This matrix right here that we just found, the inverse, times which one? The one with the 9 or the one with the -1 will give us the identity. The one with the -1, that's the one we did the inverse of, right? So if we multiply this one by this one, we're going to get the identity, and that will be the identity times our variable p, and identity is like 1, right? And 1 times p would just be p. So that's how we're going to get the p to be by itself. Now, the only tricky part with this is, so we know we're going to have to take this matrix and multiply it by that one, but it matters the order in which you multiply them, okay? So multiplication has this thing where you can't reverse the order. So you know how in regular numbers, like the regular number system, if you do 2 times 3, you're going to get 6. And if you do 3 times 2, you're going to get 6. And you have the ability to reverse them as much as you want. You do not have that ability here. It doesn't work for matrices, okay? So when we go to multiply this, either we have to put this one in the front of that one, or we have to put this one behind that one, okay? And so here's how we tell. Do you see how this one is in front of P? So technically, to make the identity matrix, you have to put it in front of that. If you put it behind it here, it would be behind P, and that doesn't really work, okay? Because then you'd have the matrix, then you have P, then you have the other matrix, and you can't really multiply through like that. So it needs to go in the front. So you're going to take that matrix, and you're going to put it in the front of the other one. And so we'll put it right here to do our multiplication.
But then you see that we have to put it in the front with units.
You have to put it, say that again?
Did you say we have to put it with units?
No, that we're solving for P. This is the inverse of this matrix right here. So we're trying to get rid of this one. So if we put that matrix in the front right here and multiply those two together, this matrix with this one, we'll get all of those to go away, and it will just equal P. So we have to put that matrix in the front, so that matrix has to go in the front over here. Okay. So -1, 0, 3/5, and 1/5. And when you do that operation, you will get P, what that missing matrix is. Anybody looking at this and you're like, oh man, there's fractions? Yeah, that's a bummer, isn't it? It's all right though, we got this. So it's a 2 by 2 times a 2 by 2, so I know my answer is going to be a 2 by 2, right? And that will give me matrix P. All right. The first row is going to be super nice though. It's just a -1 and a 0. So first row times first column. And like I said before, don't be afraid to write them down, right? So -9 and 0. And if you add them together, you get -9. And then that first row, but now we're doing the second column. -1 times 4 is -4. 0 and 18, that's 0. Add those together, you get -4. So only 2 of these are going to be hard because of those fractions. All right, so now we are on the second row. And the first column. So 3/5 times 9. How do you multiply 3/5 times 9? Without using your calculators, right? No calculators on this? Using our brains. It's just a fraction. You learned it back, I don't know, probably like second grade or something like that. What is it? Yeah, you can think of this as 9/1 if you want, right? And if you're multiplying, you multiply the top and multiply the bottom. So 3 times 9 is 27. 5 times 1 is 5. So that first spot here becomes 27/5. All right. 1/5 times -2. What will that be? 1/5. I'm like not even within 6 inches of this. I'm sorry, it's moving. 1/5 times -2, right? Row times column. So we're on this one times -2. 1/5 times -2. -2/5, yes. 1 times -2, -2. 5 times 1, right? Because there's 1 below that -2. And then subtract. What's 27 over 5 minus 2 over 5? No, that's the matrix there. It got erased a little bit. That's not a negative. Yep, sorry. Yeah, 27 minus 2 is 25. 25 over 5, because remember when you add or subtract, you keep the denominators the same, right? 25 over 5 is just 5. Yeah, just 5. All right, we're going to do it again. Still that second row, but now we're going to do the second column. So 3/5 times 4. 12/5. 3 times 4 is 12 over 5. 1/5 times 18. 18/5. And we're adding these together. So we'll add the numerators because we have common denominators already. So that worked out really nicely. So 12 plus 18 is 30. 30 divided by 5 is 6. So that last number is 6. So if you take this matrix here, matrix P, and you put it in place of that P, and you multiply these two together, you will get that one. All right. Questions, comments, concerns? All right. Give me 1 second before we move on. I want to check something. Okay. We are going to continue on. This next thing that we talk about is kind of an extension of matrices. All right. And we're going to do these two. We're not going to do this last one, all right?
3/5 times over 1, not negative. 3/5 is negative.
The 3/5 is not negative. It's positive, yeah. All right, so cross off this last one here. We're not going to do that one. That would involve the use of a calculator. And in normal years, when I see you every day, we would actually teach you how to do it by hand, but we're not going to take our time for that. So, all right. So what we have is like an application of these matrices, all right? So what we have is we have a system of equations. Do you remember systems? Seeing them in Algebra 1? A little bit. So what we're looking for when we solve a system of equations is we're looking for the x and the y that goes in the first equation so that one equals 11, and then the x and the y, the same exact numbers that go in the second equation, so that one equals 6. And so we can solve systems of equations by doing elimination, substitution, by graphing, and now I'm going to show you how to do them using matrices, all right? So let's go ahead and fill in this note. So a matrix can represent a system of equations. So when you write, this should actually say when you write a matrix, or when a system, sorry, there's a little bit of a typo there. So when a system is written in matrix form, there are going to be 3 parts. All right, so if we change this into a matrix form, you have three pieces. You're going to have what we call the coefficient matrix. And the coefficient matrix is going to be all of the coefficients in front of the x's, right? Coefficients are the numbers that come in front of x's and y's. So we need a matrix that has all the coefficients. There are how many coefficients up here? Numbers in front of x or y. How many numbers are there? There are technically 4, right? Because in front of this x, there's technically a 1. And so your first matrix when you go to do this is the coefficient matrix, and it's going to be 2, 3, 1, and 2. So there's your first matrix, coefficient matrix. Then you're going to have your variable matrix. And what are the 2 variables we're trying to solve for? X and y. So you're going to have a matrix here that is being multiplied, because in these equations, this is multiplication, right? Multiplication between them. 2 times x, 3 times y. If you were to multiply this out, you do row times column, right? So 2 times x plus 3 times y. So that's how we have 2x plus 3y. So that's why we set it up like that. And then last but not least, you're going to have what we call the answer matrix or the equal to matrix, whatever you want to call that one over there. But it's going to equal your solutions, which are 11 and 6, whatever they're supposed to equal. So we have a system, and we can set it up into matrix form, and we can use matrices to help us solve this system. So if we don't remember substitution, elimination, all that fun stuff, we can actually use matrices. So what we're going to do is we're going to solve for the xy matrix, the variable matrix. And when we solve for it, we're going to have two numbers. The first one's x, the second one is y. So in order to solve for this matrix, what do we have to do? We have to get rid of that matrix, right? And right now that matrix is being multiplied. So how do you get rid of multiplication in the world of matrices? The inverse. You multiply by the inverse. So you have to take this matrix right here and find its inverse. And when we find that inverse matrix, we're going to multiply in the front, right? In the front. So if we're going to multiply the inverse in the front there, we would multiply in the front on that side as well. All right, so let's find that inverse matrix. First, we need the determinant, right? Because we're going to do 1 over the determinant. Because this matrix is sitting in the front. So you have to put it directly next to that matrix. You can't shove it in the middle, and you can't put it back there, all right? It has to go wherever this matrix is, it has to be directly next to it. And so because the easiest place to put it is in the front, we'll just put that in the front, and then that one in the front. All right, so inverse, 1 over the determinant. Determinant is 2 times 2, which is 4. 3 times 1 is 3. 4 minus 3 is 1. So 1 over 1. Which is really nice, right? Glad we didn't get fractions on this one. And then we need the actual inverse matrix. So we're going to do some flipping, right? The 2 and the 2 flip locations. And the 1 and the 3 for flip signs. And so if you go ahead and do this determinant part in the front, 1 over 1 is just 1. 1 times that matrix is just that matrix, right? So this right here is our inverse matrix, if you want to write it out for sure. Like that is the actual inverse there. All right, so if you are getting rid of this matrix, you have to put that one in the front. So if you put it over here in the front, what's going to happen when you multiply these two matrices together? This one times this one. What's going to happen? You're going to get the identity, right? Because this is a matrix and it's inverse. So that'll leave us with just the x and the y matrix. This will make the identity, which is just like the number 1. And that means that all of that will go in. You just have this piece. So over here, you're going to have to put this matrix in the front of this one before you multiply. So that one goes in the front, and then we'll multiply it by 11 and 6. So rows times columns, right? All right, row times column. First row, first column. 2 times 11. 22. Negative 3 times 6. Negative 18. Technically, we're adding, right? So we would just keep the subtraction there. 22 minus 18 is 4. So x is equal to 4. And then find y. Second row, first column. Negative 1 times 11. Negative 11. 2 times 6. 12, add those together, we get 1. So y is equal to 1. So solving a system using some matrices instead. All right, what questions do y'all have for me? Any questions at all? Okay, I'm gonna edit your homework assignment just slightly. So It's technically page 11 and 12, right? 11 and 12. And so here's what I want you to do. First piece of the homework is I want you to do this one. I know I left it there. I want you to do that, okay? Practice that one, and we'll see how you do. And then on page 11, I want you to do all page 11, all right? And then I want you on page 12, you'll do 7 and 8 completely. And then on 9, 10, 11, and 12, those are systems. Those story problems, they're systems. And so I want you to try to write this equation, just like we wrote here in red. Just see if you can write the equation to set those up. There's going to be some big numbers, so if you want to try to solve, you can. Just know that you're probably going to need a calculator to solve those ones, okay? There are no story problems like that on the test coming up, okay? So think of like 9 through 12 if you want to kind of continue on, practice, set them up. If you can set them up, then don't worry about needing to solve. If you want to challenge and try to solve it, go for it, okay? Does that make sense? All right. Everybody look at number 8 with me real fast. Number 8 is not a one-step equation like we saw in the 2 examples here. It's technically a 2-step. So you're going to have to do 2 things first. So the first thing you have to do on number 8 is you're going to have to add the matrix over, right? When you add the matrix over, then it turns into a matrix times x equals a matrix. Then you'll go ahead and do the inverse to get rid of the other matrix by dividing. So it's a 2-step matrix equation. Does that make sense? Okay. The same thing is true on number 7. Technically, number 7 is a 2-step. But once you take care of the first matrix and move it over, then you just divide everything by 4. So instead of having to divide by matrix, you just divide by a constant, okay? Does that make a little bit of sense? All right. So that'll be your homework assignment. And then on Monday, we'll have y'all work on the test review.